Hello and welcome to Normally Distributed, where we learn about probability and statistics with a sports twist. Today I am bringing you Calculating and Interpreting Probability Part 2. If you're joining us from the first part of this video series, you know that probability is a number between 0 and 1 that helps us understand how likely an event is to occur. Here in Part 2, we're going to get into some definitions. Let's go ahead and get started. And the first definition we are going to learn today is sample space.
So, the definition of a sample space is all of the possible outcomes of an experiment. And when you add up the probability of each individual outcome, they will add up to 1 or 100%. So, let's go ahead and start with an easy example to show you why this happens. Let's take the dice example. So, when we roll a die, the sample space of everything that can occur when you roll a die is actually just the numbers that can come up. So in this case, we have 1, 2, 3, 4, 5, and 6. And so we know that usually, in most instances, a dice is even odds across all of the possible options here. So 1 has 1/6 chance of occurring, 2 has 1/6 chance of occurring, and so on and so forth. Now, what we need to realize here is that when you add all of these up, they actually are going to equal 6/6 because when you roll the dice, one of these 6 things has to happen. It's an absolute certainty that you will get one number to come up. And so when you add up all of the outcomes, you get 1, 100, or 6 out of 6. Now let's go ahead and take a look at a little bit more complicated of an experiment. Let's say we want to create a chance experiment to estimate the probabilities of what happens when a quarterback throws the ball. First, we need to establish the sample space. Now, there are a number of ways that this can happen. We can have a sample space that is just as easy as a completed pass and an incomplete pass. This is probably the easiest sample space to write out for this option here, but there are other ways to write this out. For example, if we wanted to look a little bit more closely at the number of touchdowns that a quarterback throws in the total amount of passes that he throws, then in that case, we have to split up completed pass into a couple more options here. Completed, non-TD, and completed touchdown. And you can do this over and over and over again. But what you'll realize is that no matter how you split up this sample space, it will always add up to 100%. So we start with completed and incompleted, and the probability of completed, let's say, is 60%. That means the probability that an incomplete pass will occur is 40%. And that's what you usually see with good quarterbacks. But then also, if we want to look at completed non-TD and the percentage of those, or completed touchdown and that percentage, we can split up the sample space even further to really understand and look at what probability is we are interested in. So another word that you'll hear a lot in probability is called an event. And the definition of event is that it is one or more outcomes of a chance experiment. Now, going back to our football, another word that you'll hear a lot in probability is an event, and that is something that we do need to define. Now, an event is one or more outcomes of a chance experiment. So, going back to our passing example, our quarterback example here, in our sample space, we have a number of things. We have a completed pass for a touchdown. We have a completed pass, not touchdown. We have an interception or an incomplete pass. Now, that is all in our sample space. So we can set the event as anything that we want. So if we want to set up our chance experiment to calculate the probability that the quarterback will complete a pass for not a touchdown, then we would just look at the number of times that the quarterback threw a pass, completed it, that it wasn't a touchdown. But on the other hand, if we wanted to look at a bigger event here, With more than one outcome, we can look at the probability that the quarterback completed the pass in general. And so what we'd end up having here is the number of times that the quarterback threw a completed pass for a touchdown and the number of times that the quarterback completed a pass for a non-touchdown or just the completed passes in general. And so the single outcome here would be in each chance experiment or in each throw, what happens when that quarterback throws the ball, whether he completes the pass or whether he doesn't, whether he completes the pass for a touchdown, non-touchdown, whether he throws an interception. Those are outcomes. But an event is something of interest with one or more outcomes that we calculate over the entire number of observations that we take. So the event can be, again, completed passes, how many completed passes he had as a total of the passes that he threw, or the number of incomplete passes that he threw over the total of passes that he threw in general. So let's look at another example of this. Let's say we have 10 people on a basketball court, and player A shoots the ball and misses. Let's say that every single player on the court has an equal chance of getting the rebound. So every single player on the court has a 1 in 10 chance of getting the rebound because there are 10 players on the court, all of them have an equal chance. So let's calculate the probability that player A receives the rebound after missing his shot. Since player A has a 1/10 chance of getting the rebound, the probability that he does get the rebound, which is our event, is just 1 over 10. Pretty simple there, right? All right, so that one was pretty easy, right? If the event that we were interested in is whether or not player A received the offensive rebound after he shot it, he obviously only has a 1 in 10 chance since they all have an equal chance of getting the rebound. But what if we wanted to look at whether the offensive team in general, what their probability of getting the rebound was? Again, let's remember that everybody has an equal probability of getting the rebound. So with 5 people on the offensive team, each one with 1/10 of a chance, each of them with 1/10 of a chance to get the rebound, the probability that the offensive team gets the rebound is actually just the sum of all of their individual probabilities. And so this ends up being 5 out of 10 or 50%, which means if all things are equal, the offensive team has a 50% chance of getting the rebound. Again, if we remember our probability scale, that means they have the same chance as the defensive team to get the rebound as equal that they get it as they do not.
Thank you for watching. This has been Calculating and Interpreting Probabilities Part 2. For some practice problems and some extra learning resources, please visit the website. If you like this video, hit subscribe or like. Thank you very much.